Assalamualaikum warahmatullahi wabarakatuh. I bid to Dr. Sabrina and Madam Elmi. Before I go further, I would like to introduce myself first. My name is Atiqah Aina binti Zailani. Today, I will be presenting my proposal summary for FYP1. The title is Organic Removal Using Advanced Oxidation Process by the combination Persulfate and titanium dioxide. For introduction, the previous researcher had estimated the solid waste generation will reach 31,000 tonnes per day by 2020 from the fast urbanization and population growth. The major hazard generated from municipal solid waste landfill is the untreated leachate according to the previous researcher, as it may contaminate the groundwater and surface due to dissipation of leachate through soil and then becomes the significant threat to the environment and the ecosystem. As we know, leachate have the recalcitrant pollutant that are very difficult to remove by the conventional treatment method. However, advanced oxidation process is the effective method that can degrade these pollutants. Moving on to the next slide is about literature review. Advanced oxidation process, known as AOP, is the oxidation and degradation of the inorganic and organic compound that are resistant to the conventional method treatment. AOP mainly produce the hydroxyl radical which aid to degradation process until the target pollutant are completely converted to the water, carbon dioxide and also mineral salt. According to the previous researcher, the pesticide, inorganic substance and coloring matter can be recovered by this process. The most popular technology in AOP is the combination of the strong oxidizing agent with the catalyst and elucidation. Example of this popular technology is the Fenton reaction, the combination hydrogen peroxide with the UV light process, and the combination of the titanium dioxide with the UV light process. The some advantages of the AOP is the significant reduction of inorganic and organic compound, and also complete mineralization of organic contaminant to the carbon dioxide, water, and also mineral salt. This slide is about sulfate radical and titanium dioxide. Table 1 shows the oxidant and their oxidation potential. Hydroxyl radical have the higher oxidation potential, which is 2.8 compared to the chlorine and also permanganate. However, sulfate radical generating from the activation of the persulfate has the higher oxidation potential among all the oxidants. It can be from 2.5 until 3.1. Sulfate radical may initiate production of other intermediate reactive oxygen species, which is hydroxyl radical. Reactive oxygen species can initiate a series propagation and termination chain reaction where organic are partially and even fully decomposed. This study had been observed by the previous researcher where the rapidly degradation of the trichloroethylene, which is the organic pollutant, that can be formed from the paint remover. Moving on to the titanium dioxide, the advantages is the chemical stability, non-toxicity, high photocatalytic activity, and environmentally friendly among all semiconductor photocatalysts. The best result is when the titanium dioxide they are subjected to the UV spectrum. Organic pollutant will oxidize as the hydroxyl radicals are generated on the surface of the semiconductor. The problem statement of this research is the recalcitrant compound. New chemicals are continuously being introduced to the environment. That's why the environment are getting polluted. Recalcitrant compound can be found from the pharmaceutical, personal care product, and also pesticide. Recalcitrant compound is a very toxic and biorefractory that are difficult to remove from the conventional treatment method. Advanced oxidation process is the effective method can degrade this pollutant. However, persulfate has limited effectiveness. The previous researcher had suggested the persulfate oxidation must combine with the other treatment process in order to effective this degradation. Moving on to the research objective, the first objective is to evaluate the optimum condition for chemical dosage, pH, reaction time and shaking speed from combination of the persulfate and titanium dioxide. Second is to analyze the reduction efficiency for COD, TSS, color and ammoniacal nitrogen from level leachate by applying response sequence methodology. And third is to determine effectiveness of persulfate and titanium dioxide in removing organic compound of level leachate using advanced oxidation process. The novelty of study is when we referring to the journal, the previous researcher had observed the combined persulfate oxidation with the aluminium sulfate, ozone and hydrogen peroxide. However, the combination persulfate and titanium dioxide has not been investigated yet. That's why this study is conducted to observe the performance of this combination. The methodology for this research is first sampling of leachate where I need to collect the sample at the quality alam. Second is a pre-characterization of leachate where I need to identify the initial value for all the parameters. Third is advanced oxidation process. Before proceeding with the advanced oxidation process, I need to run the FCCD first. FCCD is the phase central composite design that will give the suggested the desired value for all independent variable, which is the pH, reaction time, shaking speed and also the chemical dosage. Next is a post characterization where I need to identify the final value for all the parameter after the oxidation process completely, and then calculate the removal efficiency. After that, I need to insert the removal efficiency for all the parameter into the RSM, and then RSM will generate the optimum condition for all the parameter. And lastly is the discussion about the effect of the independent variable with the parameters. The expected result for this research can be looked at the table 2. Table 2 show the persulfate alone oxidation and the combination of persulfate oxidation from compilation of previous study. The first process is the persulfate alone oxidation had lower reduction efficiency compared to the combined persulfate oxidation with higher reduction efficiency for all the parameters. The effect in this research can be divided by the 4 points. The first point is the chemical dosage. As increasing the chemical dosage, the performance of oxidation will increase. However, increasing the chemical dosage will increase the turbidity of the solution. The next point is the pH. Alkaline activation is a very productive in generating sulfate and hydroxyl radical at the higher pH condition, which is pH 11. The next point is the reaction time. As the reaction time increases, the removal for all the parameters are improved. According to the previous researcher, reaction time increased leading to the improvement of the degradation of organic ammonia and decolonization of leachate. Last point is the shaking speed. As the degradation increases, the shaking speed also increases. This is the estimated cost in this research. The grand total for this research is the RM 359 ringgit and 18 cents. The item is a sodium persulfate, titanium dioxide, LED lamp and also petrol where I need to collect the sample at the quality alam. As the conclusion, the combined persulfate process demonstrates the most efficient use for stabilized leachate treatment compared to the persulfate alone. The combined persulfate improve biodegradability will have higher reduction efficiency compared to the persulfate alone at the table 2. The combined persulfate and titanium dioxide expected to be the same efficient from the combined persulfate in the previous study. This is the GANTT chart for the FYP1 and FYP2. We can see at the FYP1 table on the week 7 is the proposal presentation conducted via online. Week 15 is the final proposal presentation. This is the reference that I use in the slide presentation. That's all from me. Thank you.